Hi, today we're going to talk about the logarithms, and for this day we're going to take up properties of logarithms. So we'll have these properties here discussed, no? The natural log and the logarithm with base 10, no? Or base a, no? We have this property, the product property, the logarithm of a, logarithm base a of any product here is equal to logarithm of sum, no? Uh, the sum of their logarithms with base a, no? That is similar to natural log, no? The quotient property states that logarithm with base a of any quotient is equal to the logarithm, the difference of their logarithms with base a. No? And always remember also that a is positive, you know, and not equal to 1, no? So here in the power property, the logarithm with the power u, the power n, is you just bring down this power here and the logarithm of u with base a, no? Similar to this natural log, no? So natural log with base e, no? So we have two sets of problems here. The first one, we will express as a single logarithms of all these things here. No? So we are given logarithm of x base b plus logarithm of x plus base b plus logarithm of 7 base b. All we have to do, no, since we're going to apply the product logarithm, no, so we get the product of these three the entities x, and 7. So that will be equal to logarithm base b of 7x squared. No? For number 2, we have here the logarithm of a quotient, no, is equal to the logarithm of the difference. No? So the logarithm of the difference is equal to logarithm of x over y base b. So for number 3, we have 3 log of base b of x plus 2 plus 1 half of logarithm of x base b is equal to all we have to do is change this to the power logarithm, so it becomes logarithm base b of x plus 2 raised to 3, no? The coefficient there, no? Plus this 1 half here become the logarithm of b. This one becomes the power of x, no? Logarithm base b of x is 1 half is equal to, so this one remains the same, no? And we'll convert this one to a product, no, with square root. This one will be expressed in radical form, square root of x, no? So just rearrange logarithm base b of square root of x times x plus 2 raised to 3. For number 4, you're given 4 times logarithm base b of 2x plus 1 minus 2 times the logarithm of x squared plus 1, no? Quantity, no, is equal to logarithm base b, no, of 2x plus 1. So this one becomes the power of 2x plus 1 minus, no, we just copy again, minus logarithm base b of x squared plus 1, and this 2 here becomes the power of this parenthesis here is equal to logarithm base b. This one becomes the quotient, no? We apply the quotient property to x plus 1 raised, no, x squared plus 1 quantity squared. For number 5, we have here logarithm base b of m minus logarithm base b of x m minus 1 minus 5 logarithm of base b of m minus 3. So this one becomes the logarithm of the quotient. But first, we're going to express, no, this one to the power formula, no? So this one becomes logarithm base b of m minus 3. This coefficient here become the power of this parenthesis here now. So next, this expression here becomes the logarithm of the quotient of m. Since this one negative becomes the denominator m minus 1 times quantity m minus 3 quantity to the raised to the fifth. So for b, set b, expand each expression. We are given natural log of z times quantity z minus 1 quantity squared, where z is greater than 1, no? Because you don't have a logarithm of a negative number. If this one is not greater than 1, it's less than 1, so if this one becomes negative, it is not allowed because we don't have any logarithm of negative number. So that one becomes the natural log of z plus natural log of z minus 1 quantity squared, no? So becomes the sum, no? This quotient, this product here becomes the sum. And then we bring down these two, so natural log of z plus 2 times logarithm natural log of z minus 1. For number 2, we are given logarithm base b of this quotient here, square root of a minus 1 over 9, where a should be greater than 1 since we don't have the square root of negative numbers. So this one we just expand, no? This one becomes negative in sign, logarithm base 2 of the square root of 1. So logarithm base 2 of 9 minus, no? So this one we express as the power, no? Logarithm base 2 of a minus 1 raised to 1/2 minus logarithm base 2 of 3 squared. We just express this as exponents, no? Of 3 squared. Then bring down again this one, 1/2 of logarithm base 2 of a minus 1 minus, so we bring down these 2 here, the exponent of 3, 2 minus 2 logarithm base 2 of 3. For number 3, we are given logarithm base 2 of x to the 4 times the square root of y over z cubed, no? Is equal to, so we transform this into exponents, exponential form, logarithm base 2 of x to the 4th. So this one is square root y over z cubed raised to 1/2 is equal, no? Logarithm base 2 of x to the 4th. So this one we separate the numerator from the denominator, y to raised to 1/2, and this one becomes z raised to 3 over 2 is equal to the logarithm. So this one is the product becomes a logarithm of the sum. Logarithm base 2 of x to the 4th plus logarithm base 2, this one is 1/2 minus the denominator minus logarithm base 2 of z raised to 3 over 2, no? So we just simplify all this thing here. So this one becomes logarithm base 2 x to the 4th plus, no? We change again to radical form, logarithm base 2 of square root of y minus logarithm base 2 z, no? Logarithm base 2 of z of square root of z raised to 3. So that's all for now, no? That's how we're going to tackle, no? These logarithm problems using the properties of logarithms. So thank you for watching. So please subscribe to my YouTube channel by Wilfred Tan, and don't forget to subscribe, no? And also if you do want to give some comments, it will be greatly appreciated. Thank you.